Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on the area of a trapezium. So our first slide is obviously going to give you the formula for the area of a trapezium. I have drawn two separate trapezia here so that you can see that they do sometimes look a little bit different. As you can see, the one in the middle is probably the most common one, the one you're more likely to recognise as a trapezium. However, also remember that a trapezium can look a bit like the one on the left, where it kind of looks like a rectangle for 3/4 of it, but then it's got one slanted side instead of two. Okay, so I've got both of these here. They're both each a trapezium. They just look slightly different. So make sure you recognise it when you are given it in the exam. Now, the actual area of a trapezium, the formula is A plus B over 2 times specifically the perpendicular height. So we're going to break that down. A plus B, first of all, you're thinking, okay, yeah, but what even is that referring to? As you can see, I've labelled it on these two diagrams here, and you can see over on the right-hand side, it says A and B are always the parallel sides. Okay, so some people say, oh yeah, A and B are the top and the bottom of the trapezium. Well, in the case of these two diagrams, yeah. However, you could have a trapezium that stood upright, and what I mean by that is it could look like this, for example. In which case, the parallel sides, do you see, are not the top and the bottom, but the left and the right sides. Okay, so just be careful, you know that A and B are more specifically the parallel sides. Whichever way they are rotated, it doesn't matter as long as they're parallel. It doesn't matter in that case which is A or B as long as the two are correct, being A and B. So like, for example, I could put that as B and this one as A. That's fine, because either way, they both have to be A or B. So we're going to add those together and half them, or divide them by 2. What that's actually doing, this bit here specifically, is effectively finding an average. Because as you can see, obviously A and B are normally, well, they shouldn't be, the same length. Otherwise it would just be a rectangle. So you're effectively finding an average between those two parallel sides that are different lengths. What is kind of a halfway point between them? Like the midpoint, if you imagine it like that. So you're going to do A plus B divided by 2 to find an average for, in this case, let's call it the length. Then you're going to times that by the perpendicular height. Now, in the case of the left-hand trapezium, that's quite obvious which is the height. It's just one of the sides. Now, if you've seen our other videos, especially when we looked at area of triangles and parallelograms, things like that, whenever you have diagonal sides, we never use those measurements to find area. They always have to be perpendicular measurements. So even if they told you, let's say on this left-hand diagram, they told you the length of this one, that's not the height, okay? You always have to go with perpendicular, which is why I've drawn this right angle here. Now, in the case of the second trapezium, which looks slightly different, obviously neither of the two sides are the perpendicular height. They're both diagonal sides, aren't they? So we need to ignore those, and that's why you can see I've got this dotted line here, this paler line. Now that's meant to obviously go down to the bottom. But you can see I've drawn this 90 degrees box as well, this perpendicular height. It might not always be an actual side, it might just be a vertical or perpendicular measurement. Okay, so the same as you would have seen with triangles and with parallelograms. We're never using diagonal sides for the height or for any kind of area measurement, okay? In the case of this one I've drawn at the bottom, where it's obviously still a trapezium but rotated, the height in that case, let's say if that was a right angle, would be this. Now I know that's obviously a cross, isn't it? But in that case, that is the height. And this example is very specific for when you do the topic of finding the area under a curve, or sometimes they call it finding the area under a graph, or finding the distance from a graph. You normally have to split the graph up into multiple trapezia, and they're always like stood up vertically like this. We won't be touching on that in this video, however that is a higher tier topic where you have the area under a graph. So if you are foundation tier, just ignore what I've just said about that. Today we're just purely focusing on finding the area of a trapezium with this formula. So I've got the formula in the corner of the screen as well, however make sure you have got it noted down somewhere. Obviously here I've just shortened it to h for height, but remember that is the perpendicular height. So for this first one, work out the area of the trapezium. Okay, well first of all I need to label the sides or the measurements that are relevant to me. So first of all, A and B we said are the parallel sides. In that case, that's obviously going to be the top and the bottom here, because these are parallel sides. And then obviously here we actually have a side which is a perpendicular side, so I can use this one as the height. And then we're just going to put it into our formula. So area is 9 plus 13, so A plus B over 2, so that will find the average between the two sides, the top and the bottom, times by the height, which is 10. So then grab your calculator, I'm going to type it in here. Obviously this one I think we could work out ourselves. This question could still come up on a non-calculator paper if they use nice enough numbers. I'm just going to show it here though. I'm just going to work out the first bit, the a plus b over 2, just so you can see. 9 plus 13 over 2 is 11. Do you see how 11 is exactly the middle of 9 and 13? It's like the halfway point, isn't it? A midpoint, or effectively the average. And then you take that, so we're saying, right, the average of the horizontal sides in this particular question is 11. I'm going to times it by 10. So actually, it just relates back to the same formula that we use for rectangles, length times width. It's just that we have to first of all work out what is the average length, because obviously you've got two different options. So if you wanted to know kind of why we do that, that's the reason. Otherwise, don't worry, you don't need to try and explain it yourselves. Either way, the answer is 110 centimeters squared for this one. Okay, that's literally it. As long as you get the sides correctly labelled and then therefore you put them into the formula correctly, that's really it. Okay, so the next question, we've got a slightly different looking trapezium, although obviously it still is a trapezium all the same. This time we have two sides which are diagonal, hence why we have this additional measurement in the middle here with the dotted line. So work out the area of the trapezium. So I'm going to label my sides first. So A and B are the parallel sides. So again, in this case, they are the top and the bottom, aren't they? So we've got A and B. Doesn't matter which way round those go, as long as A and B are the 7.5 and the 15.4. And then in this case, the perpendicular height is not one of these sides, is it? Because those are diagonals. It's actually going to be this dotted line here, the 9.2. And once I figure that out, I'm just going to type it into the formula again. Over 2 times by 9.2. And then we put it back in the calculator. So I am going to write the whole thing in this time. Times 9.2, there we go. We get 105.34. Obviously that one was more of a calculator one because of the decimals. And there we go. Okay, this is a good example of a trapezium where it's been stood upright. So it looks a little bit different, but it is still a trapezium. Now, working out the area of the trapezium, again, we're going to label A and B. But this time, do you see how A and B are not the top and the bottom? Because obviously the 2.5 side and then this diagonal side are clearly not parallel, are they? So the A and B sides are actually going to be the left and the right-hand sides, because those two are parallel. Okay, so that's why I hesitate to say, oh, the top and the bottom, because it's not always the top and the bottom of a trapezium. More times likely it is, but it's not always, so just be careful with that. So A and B are those two parallel sides, which in this case are the left and the right-hand side, and then therefore the height, the perpendicular height, which we have this right angle here, so we can see, is actually this side in this case, so 2.5 is the height. Okay, so I know height is normally a vertical measurement, but it could be that if the trapezium has been rotated, you have to think of the height as the distance between the parallel sides. Okay, and then once we've correctly labelled all the sides, then we're just carrying on as we did before. So A plus B is 12.5 plus 8.5 over 2 to find the average, times it by the distance between them, which is 2.5. And there we go. So in the calculator, we get 26.25 centimetres squared. There we are. So this question is a little bit harder because we've actually been given the area of the trapezium already. They've said it's 46.1 centimetres squared, and actually now we have to work backwards to find out the height of the trapezium. So what I'm going to do is I'm still going to label the sides. So I know that A and B are the parallel sides. We can put A and B as the top and the bottom in this particular case. These two are parallel. And then they've obviously already labelled the height for us. So I'm going to fill out that formula. So I've got A, which is 4.9, plus B, which is 8.1, over 2, times by the height, which we don't know, so I'm going to leave it as H. And then on the other side, where this would normally be like the area, isn't it? Well, I actually do know the area. So in this case, I'm going to put 41.6 in that place. And that's where I get an equation from. So the only thing missing in this equation, the only thing that's unknown is the H, the height. Once I've done this, I can almost forget about the context of being area of a trapezium or area of anything. I'm just thinking about, okay, how do I rearrange this equation? Well, if I want the height, and I obviously am solving an equation, I want to get the height on its own on one side. Do we see how we've got the relationship between the height and this fraction is kind of like this? They're multiplied, aren't they? So what I might do first is just work out this fraction as a number anyway to simplify it. So in my calculator, I'm just going to type that in. You don't have to, but I'm just going to write it in anyway so I can see if it gives me a nicer number. Okay, that gives me 6.5. So I'm actually going to rewrite this. We get 41.6 equals 6.5 h. Now, hopefully that's a bit clearer. Sometimes the number here, if you put it in the calculator, might be loads of decimals and it's probably not worth it. It might be better to leave it as a fraction, but in this case, I knew it would be a nicer number. So if you look at that, that's just a straightforward linear equation. If I want h on its own, I need to move the 6.5. And the 6.5 is currently multiplied or timesing with the h, isn't it? So to move it across, I just need to divide. So I'm going to divide both sides of my equation by 6.5. Obviously on the right-hand side, 6.5h divided by 6.5 is just h, isn't it? That's the whole point. But on the left-hand side, I'm obviously going to have to use the calculator. 41.6 divided by 6.5 gives me 6.4. And there we go. It says work out the height. Well, there we are. We've got the height. Okay, so the answer is 6.4 centimeters for the height. And that is it. So as long as you're happy with not only using this formula to find the area, but also using this formula to work backwards when you're given the area and having to maybe find the height or one of the other letters, then that's also really important. So that is everything we need to know on finding the area of a trapezium. The next part of the area topic is finding the area of a sector, which will be linked here. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.